So we're going to start off by talking about and defining a function itself. When you're talking about a function and defining that, we're going to be dealing with connecting it to what we did yesterday. Yesterday we dealt with relations. A function is just basically like a special relation. Just like when we dealt with numbers, we had very special little numbers at the very bottom. Those natural numbers are part of the whole numbers, are part of the integers. This is the same concept. Functions are part of the relations group. So it is going to be, if I can get it to connect, sorry guys. Cut off on me. There we go. It's going to be a relation, which means it's going to be a set of ordered pairs. That's the first thing you need to know. It's just basically a special set of ordered pairs. It is a relation in which each member of the domain, guys, the domain is the what? What makes up the domain? The x's. So each member of the x's, each member of the domain is paired I'll say it again just to get everybody caught up with us. A relation, which is a set of ordered pairs, bless you. A relation, which is a set of ordered pairs, in which each member of the domain, the x's, is paired with exactly one member of the range. Guys, what are the range? What's in the range? The y's. So in a function, the x's have to pair up 1 to 1 with the y's. Okay? The x's cannot repeat. Okay? That's all fancy words, guys. That's all fancy words to say this. Domain does not. Am I making it clear? This is what you need to actually know out of this. That's the fancy definition. This is how you remember it. The domain does not repeat. If the domain repeats, then it is not a function. If the domain repeats, it is not a function. Alright, and let's think about this, guys. If you have an x equals line, a Buck's line, what direction does it go? Vertical, thank you. And that vertical, that's very good, because most people don't get the vertical line has all the same x on it, all the way down. Okay, think about it. Vertical lines is x equals 5, x equals 4, x equals 3, x equals 2, and going down all the way down. Okay, so because of that, you cannot have any of the same x's, so you can't do vertical lines. You can't have the same thing vertically. If you have 2 points that are on the same vertical line, that's not a function. We're going to talk more about that as we go forward. There's something called the vertical line test we're going to use. But that's what we're going to be dealing with, is no repeats in the x's. Okay, first thing we got to talk about is a discrete function. Guys, a discrete function is going to be a function that is just a set of unconnected points. A function that is a set of unconnected points. So remember yesterday we graphed all those things and they had different points in different places. This is a discrete function where all the points are there but they're not connected to each other. That makes a discrete function. If they are continuous, guys, what does continuous mean? Keeps going, doesn't lift, doesn't stop, all those things. A continuous function is going to be a function that is linear. Guys, what's linear mean? What does the word linear mean? What's the first 4 letters in linear? Line. It makes a line. Okay, it's a function that is linear or a curve, which we haven't graphed any of those yet, but we're going to. That's quadratic equations. We're coming up on that. Parabolas. We're going to be doing that soon. Okay. These look like this. Continuous functions look like a line, parabola. It's a happy parabola because it goes up.
A what?
Parabola. It's a quadratic equation. An equation that looks like this: x squared plus 2x minus 3. That, when you graph it, makes this little curve. It's called a parabola.
Are you doing that?
Mm-hmm. Yep. It's actually not bad. It's just plugging in numbers to an equation. It's not bad at all.
What's it called?
Parabola.
Just graphing a different line.
It's graphing with points. That's all it is. And you just draw a curve. And you only have to graph about 5 points on each one. It's not bad at all. It's really not as bad as it looks. And the nice thing is they're exactly the same on one side or the other, so they reflect across. This is an equation of an absolute value equation. Some of y'all have not seen this ever before. When you graph an absolute value equation, it makes a V. You may remember it, absolute value, V. Because it's the positive side and the negative side. It has those two cases and they're opposites of each other. That's why it does the V. Okay, these are all continuous functions because they keep going, they don't ever stop, but they don't repeat in the X. Okay, anybody have any questions, concerns? Anybody still writing?
I remember the first one.
We're about to get to that. Okay, here we go. So for the next one, oh wait, anybody? I didn't ask. I asked, but I didn't look. Anybody still writing? Okay, here we go. So for the next one, all we're doing is deciding is it a function or not, and then you got to give me a reason. You have to be very specific in your reason on your test, so please listen when we write down these reasons and write it down correctly. So when you're looking to decide if something is a function, the only thing we said we cared about was that the domain does not repeat. So the only part you're looking at is the x's. That's the only part we're going to look at. Do the x's repeat?
Yes. No.
No.
Oh, yeah.
Yes, they both have a 0. So is it a function?
No.
Okay. I'm sorry. Do you need, I don't know why we let him move you. Do you have glasses? You okay? Okay, so 0 and 0. Okay, if that's 0 and 0, then it repeats. So this is going to be a function? No. And the reason, you have to say it very specifically, 0 repeats in the domain. Guys, it doesn't matter if it repeats in the range. It matters only if it repeats in the domain. Okay? And I have to be specific. You have to tell me what number repeats if it repeats. Don't just say the domain repeats. I'm not going to give you credit for that. Okay, the next one. Yes or no on a function?
No.
No. Why?
2 repeats in the domain.
2 repeats in the domain. Okay. Yes or no on the next one?
Yes.
No.
Yeah.
Oh, firm no.
Okay. The answer would be yes. Where does the number repeat?
No.
In the range, and it doesn't matter if it repeats in the range. The 6 is the only number that repeats. It's the only one that's got 2 lines going to it. So that's the only one that repeats, and it's in the range, so it doesn't matter. So what you would say is domain does not repeat. Domain does not repeat. We don't care if the range repeats. We only care about the domain. Making it clear that in a function the domain is what matters. Domain. Okay, guys. So, besides using just the actual numbers in the problem, there are also going to be times when you're going to see graphs, and you're going to have to decide things based on the graph. In order to do that, we're going to use what is called the vertical line test. I'm going to be honest with you right now, the easiest thing you can do is take your pencil, lay it down on your paper, and do this, just like I'm going to drag this across, and look at this as I go through. It is going to either pass the vertical line test, or is going to fail the vertical line test. It will pass if it hits only once. It can hit 0 or only once. Okay? It is going to fail if it hits 2 or more. Guys, as soon as it hits 2, it's failed. Okay? So as soon as you hit 2 vertical points, it fails. Now I only have 2 examples on here, but I'm going to have a lot more that we kind of draw out here to the side to practice a little more. You can either just pay attention to or sketch. I just wanted to couple in your examples, but we will go over a few extras. So watch as we go through this. So I'm going to take my straight edge, this is my vertical line, I'm going to drag it across. At this point right here, how many points am I hitting right there on that axis? 1. At that point I'm only hitting 1. So at this point it is still a function. Out here, it's hitting 2. So does this pass or fail? This fails. So this, is it a function, yes or no?
No.
So you put no, and the reason that you put down is fails the vertical line test. Now they will let you abbreviate that if you write it in all caps. It has to be VLT in all capital letters. It must be in all capital letters. Fails the vertical line test. Fails the VLT. Okay, when you drag it across and you get to this one, now guys, I know that your drawing of this is not great because you're on something that's this little and this is big. So I need to be very clear on how this looks. This is a line that goes from the edge of the graph to here with a solid dot. This is an open dot that goes to the solid edge of the line. So right here, how many points am I hitting here? What about here? What about here? How about here? What about here? 1. Because it's open, it's only 1. Because it's open, it's only 1. Guys, the reason this is considered open, considered to only hit 1, this is a solid dot. Remember, when you have a solid end, that's part of your graph. When you have an open end, it's like having a border between something. It's just like the edge, the fence post, it doesn't go to either one. So this point right here is an open dot. It's not part of the graph. So there is only 1 point vertically on the axis that is actually part of your answer. So when it's right here, I can't find my tool, there it is. When I'm right here on this spot, 1 is open, 1 is closed. Therefore, is this a function? Yes. And the reason would be because it does what? Passes the VLT. Vertical line test. Guys, this is called a step function. You'll see it more when you get to Algebra 2. You're going to see them where they do this thing. It repeats where it's got like a solid end here and an open in here. Then it repeats again. A step up from that. You'll graph these and solve these and graph these in Algebra 2. They look like this though. You don't have to draw this. I'm just showing you what that comes from. There are graphs that look like that. They have a certain type of equation. Okay. Okay, let's do a couple more to fill in some of the ones. I wanted to make sure I did a few more. You do not have to write this, but just watch and pay attention. If I look at this one, parabola, happy parabola, pass or fail?
No, that passes.
Pass. This would pass. Okay. What if I do a one going sideways? Fail. Okay. What if I do a absolute value that goes down? Pass or fail? Pass. If I do one going sideways, obviously fail. We do get some guys that look like this later on. Look, if I do this, am I ever going to hit more than 1?
No.
So this would pass. Now that's a more advanced equation, but just so you know. Okay, look at this one. Pass. What if I do one like this? Fails immediately. Guys, it's a vertical line itself. If it's a vertical line, every single point is going to be at the line. So that is definitely going to be a fail. Okay, guys. So the last thing that we got to deal with today is going to be function notation. Let's go ahead and show you those. So look at your last thing that's part of this notes. This is going to be a new way to write an equation. Guys, this can either be easy or hard. Do you remember the problems that used to say evaluate? Okay, and when you said evaluate, you had to do what with those numbers? How do you do that? If I said x plus 3, evaluate for, well, if I could spell, where's the L? There you go. Evaluate for x equals 7. What would you do? Put 7 in. You'd plug it in. It'd be 7 plus 3 and your answer would be 10. That's the concept behind function notation. It is going to be about substituting in a number and then getting the other answer. Okay? So when you look at function notation, it can be written as f of x, g of x, h of x. It actually can be any letter, but those are the three that you're going to see the most common. You need to know that each one is different. So if you have a function that's f of x, you don't plug in numbers that are g of x to it. If you have one that's g of x, you don't plug it into f of x. They're separate. They have different letters. You don't plug them into each other, guys. Okay, so this is what function notation looks like. If you had the equation y equals 3x minus 8, function notation would just be f of x equals 3x minus 8. All they're doing is replacing the y with this new way to write it that says f of x. That's it. That's the only difference.
That's the answer?
What is it? There's no answer here. All I'm doing is showing you what it looks like. This is not, we haven't done any work yet. This is just what it looks like. Guys, do you understand that y is the same thing as f of x? They're just the same thing. It's just a different way to write y equals. That's all it is. It's just y equals. Let's see if we can apply that. So if I told you, I'm giving you, that the domain of this problem is going to have the numbers -2, 0, and 3. -2, 0, and 3. First of all, what does the domain represent? The x's. So I'm giving you 3 x's. And I want you to find the range. If I want you to find the range, what am I asking you to find? The y's. All you're going to do is plug them in and then get the other answer. To do that, this is what it looks like. This is what function notation is made for, guys. Watch. F of. I'm going to plug in a number for my x. That first number is going to be -2. So I'm going to replace the x on the other side with a -2. I'm going to substitute that in right there. -8. And then all I do is use my calculator to get an answer. Grab your calculator. Okay, from there, type 3 times 2 negative minus 8. Do not hit equals in the line. You only hit equals at the end.
Wait, you said type what?
3 times 2 negative minus 8. What you get? -14. There's your first y. Guys, the first y is equal to -14. Guys, what does it tell you? Look, it gives you the ordered pair. Do y'all see it gives you the x and it gives you the y? When x is -2, y is -14. When x is -2, y is -14. Let's do another one. So if I said f of, what am I plugging in next, guys? 0. That's equal to, 3 times 0 minus 8. Because what's 3 times 0, guys? And 0 minus 8 is -8. So when x is 0, y is what? One more time. When x is 0, here's our x. Y is -8. Okay, last one. F of, what am I plugging in?
3.
So it'd be 3 times 3 minus 8, which means f of 3 equals, so now I've got an x that's 3. What does my y solve out to? 1. There we go. So when x is 3, y is going to be 1. So my range for this problem is going to be -14, -8, and 1. It's not. It's just that it looks different. That's what bothers people. Anybody else? Okay. So we're going to have two sets of problems. The first one's a little more direct. The second one has a little bit more in it. It has some variables to plug in, some other things. So let's start with this first one. We're plugging in this one to f of x. Remember, if you have some that are f and some that are g, you got to plug the right numbers into the right one. This one is f of x, so we're plugging into the one that says f of x. So here we go. F of 4, because I'm replacing it with what it says right here, 4, is equal to 3 times 4 minus 4. All I did was replace this 4, this x, and this x with 4 and 4. That's all I do. Then I just work it out to get an answer. F of 4 is equal to, guys, what's 3 times 4 is 12. 12 minus 4 would be 8. 8. Nice. Okay, do the same thing. We're plugging into the same one because it's still f of x. So we plug into that same one, but instead of plugging in a 4, we're now plugging in a -5. So it's going to be 3 times -5 minus 4. So f of -5 would be equal to what's 3 times -5 minus 4?
Oh,
-19, right? I think you were giving me the first step, right? So -19. He was just working through the problem. Y'all be nice. Come on. For the last one, things are different, guys. You're going to have to distribute. You're going to have to use a property. You're going to have to do more. You're going to have to leave your answers where you don't have it come down to one single number. So watch carefully. This is f of 2 minus x. So wherever the x is, I'm going to replace it with 2 minus x. So it's going to be 3 parentheses 2 minus x minus 4. I'm taking and I am replacing this x with the 2 minus x. Now to work that out, again, I'm not going to get just an answer where it's just a number. It's not going to happen like that. It's going to be different than that. We're going to have to do more work. We're going to have to get more of a different type of answer. So it's going to be 3 times 2, which is going to put us at 6. 3 times x, got to be careful, it's a minus right there, so 3 times x is going to be minus 3x, and then the minus 4 goes on the end. Guys, what's it called on the next step? Combine like terms. Combine like terms. I need to combine this 6 and this -4. Which term is going to go in front, the number or the variable? Variable term goes first, so we write that -3x in front. And then 6 minus 4 would leave us 2. Since it's positive, it would be plus 2. Very good. Can I go any further? No, because one has a variable, one does not, so I can't go any further. I would leave my answer like that. Okay. Anybody before you go? Yep. Huh? How did I get the -3? I multiplied this 3 right here across this negative x right here, and 3 times that negative x or minus x turned into minus 3x. Is that distributive property? Okay, guys, I want to do something real quick. I just want you to watch. This is not an example you have to have written down, but watch. If I had this same problem and it was f of 4 minus 2, it looked like that. When I plug it in, I would do the same thing. 3 times 4 minus 4, so I've done the exact same thing over here. But the only thing I'm going to do is add onto the end of it a minus 2. So if I had this problem, f of 4 minus 2, it would be equal to, what's that, 12 minus 4 would be 8. 8 minus 2 would be 6. So they can do things like that where they add a number or subtract a number on the end. They can do so many different things with function notation. I just want you to be aware of it. Because I can't even come up with enough examples to do all the different types. I'm not going to do that. I want you to try them. Yes?
Would you leave it at this?
That My answer's 6. So f of 4 minus 2, that's the beginning part. Is that okay? Okay. Anybody else? Okay, here we go. Next ones. Okay, this time we're plugging into h of x. These are our last problems. This is a quadratic equation, guys. You see the x term that's squared, then the x term, then the constant. This is what we're going to be doing most of the third and fourth, fourth 9 weeks. We do this a lot. So this is what we're going to use to factor, to graph, to do all kinds of things. Here we go. H of negative 3 equals negative 3 squared minus 4 times negative 3 plus 5. Now guys, this is just calculator work. I need you to grab your calculators and try it. So go ahead and finish writing it, and then we need to all do this together to make sure you can type this. Got calculators ready? I'll have everybody. I'm waiting. I just want to make sure everybody sees this. Ready? Okay, here we go. Clear out your calculators. Type 3 negative squared minus 4 times 3 negative plus 5 equals 26. There you go. Okay. For the next one, it's a little different. We have a variable replacing another variable. It's okay. It's just going to have a variable in your answer. It's just going to have a y in the answer instead of a x in the answer. So it looks like this. 6y, h of 6y, sorry. It would be 6y squared minus 4 times 6y plus 5. Now, I have a question for you. Can you just type that in a calculator? No, you don't have a calculator that will do that, but you can do the arithmetic on the calculator. Most of you know some of this, though. What's 6 squared? 36. You can use a calculator to do it. Type 6, hit the square button, it'll give it to you, or 6 times 6. And then the y squared is just written literally as y squared. So what we're doing is distributing that square to the 6 and the square to the y. And then we're going to multiply the negative 4 times the 6y, and that's going to give me negative 24y. And then the plus 5 is going to go on the end. Now, the nice thing about this, because they are all different terms, there are no like terms here. One has a square, one does not, one has no variable at all. Then I can't do anything else. I can't combine anything. I'm going to leave it like that. That's a quadratic, and I'm just going to leave it at that point. It's as simplified as it can get. Okay, this last one is about multiplying. This is about the distributive property. Question before I go on?
I have a question.
Yeah, please.
Why would you leave the squares there? Like, for above 36?
Absolutely. So I have 6y times 6y. That's what 6y squared is multiplied by itself. What's 6 times 6?
That's 36.
What's y times y?
5 times 5.
There's 2 of them, so it's y squared. Is that better? It usually helps people see it, why I have to put the 2 on there. Is that good? Guys, ask me those kind of questions. It will make a difference when you try this stuff. Okay, last one. Negative 4 times h to the w. Okay? Guys, don't make this hard. It's just like having any number outside of anything. What are you going to put on the outside on the other one?
Negative 4.
Negative 4. Is the circling enough? Negative 4. Brackets. That's all it is. Put the negative 4 out in front, then do it just like you did. Guys, what am I doing? I'm replacing the x with a... Nope. I'm replacing the x with a w. I'm replacing the x with a w. So it's going to be w squared minus 4w plus 5, and then close your brackets. Now, is that a final answer? Is that as simplified as it can get? No, because what can you do when you have a number outside of parentheses, brackets, braces, anything? You can use distributive property across here. So it's going to be negative 4 h to the w. And then you're going to write this as negative 4 w squared. A negative 4 times a negative 4 is going to be a positive 16 w. And then a negative 4 times a positive 5 is going to be a negative 20. Now, is that as far as I can go? Yes, that would be as simplified as I go because that's a quadratic and we have no like terms.